In this video, I want to explore dividing by two. Now, I'm going to be talking about it in terms of dividing by two or dividing in half, because we want to be able to make that connection with our students that dividing by a two means that we're dividing it in half. Very often, our students will know their doubles facts, but they haven't yet connected the doubles facts to the half facts, so with addition and subtraction. Similar in multiplication and division, many of our students know their times two facts. When we ask them to divide by two, it causes them to pause a little bit. So we want to make sure we're having that connection between multiplication and division. Now I'm using the model here of Cuisenaire rods. I have turned on the numbers on the rods only because I'm thinking you might not be as familiar with what the size of the rods are. But please know that there is a color coding system to the Cuisenaire rods that do allow our brains to be able to retrieve from memory what those rods are. And they are trademarked by the company Hand to Mind, and Brainy Camp modeled their virtual manipulatives to the Hand to Mind official ones. So they're also called relational rods. So other websites have the Cuisenaire rods, but they're not the same colors. That's what's trademarked by Hand to Mind. So I have put the numbers on here, but I do not use numbers with the kids. I make them think about, well, what do you know? What rods do you know? That number relationships for building their number sense. But just for easy sake, as you're watching here, I want you to see what those numbers are. So here's a context, the quotative context of Kylan had 14 shoes. How many pairs of shoes does she own? How might a student enter that task? So concretely, pictorially, and abstractly. So a student might choose to enter this task in the concrete way by laying out the amount they know Kylan has for sure. So she has 14 shoes. Now we can show that very efficiently by using a rod that's worth 10 units and a rod that's worth 4 units long. Now we can use these for whole numbers, but we also can use them for fractions and decimals. So I'm careful to use that term unit. But one of the benefits of using a virtual manipulative, in addition to the physical, it's not either or, it's both and, is that they offer here this ability to have an adjusting size. So I can make this one rod here to be matching that 14 in all. So I'm just going to put that right on top right now. So I do have that total amount of 14, and I'm going to be thinking about, well, how many pairs of shoes does she own? So a pair of shoes would be two. So a student might be thinking about either repeatedly subtracting or repeatedly adding, perhaps. They may think, well, if I have two shoes, that makes one pair. If I make another two shoes, and I'm going to keep going until I see, well, how many pairs will make up that total of a 14? Right? So being able to think about this kind of in a quotative way, that every two shoes makes a pair. And then I'll be able to see that, oh, indeed, it makes 7 groups of 2. 7 pairs of shoes would make the 14 shoes in all. To explore the situation pictorially, I might draw on some 10 frames, right? 14, and I might use symbols to represent the pairs of shoes. Students are likely to begin to want to become artists and draw shoes, but we can help them see that, well, perhaps I can just be drawing symbols to represent each shoe. And so as a student has drawn these on the 10 frames, now they can be thinking about, well, how many pairs of shoes is that? So perhaps they think about, well, these two make a pair, that makes a pair, and they can be physically, drawing a circle around every two. And indeed, again, coming to the conclusion that there are 7 pairs of shoes in the 14. Another really powerful pictorial way of exploring the story situations is to model the structure of the story. So you can see here in this bottom right that I have a bar up top for shoes in all. So I'll be able to label that I know that it is 14. And then beneath it, I have pair 1 has 2. And so I might then label pair 2. I can give it a P2. And then pair 3 would give it another 2. Remember, we're dealing with equal groups right now. So each of the groups is going to be 2, but ... because what I don't know is how many pairs. That is my unknown. How many pairs of shoes would there be in the 14? And that's what I want to be able to explore. Now you'll notice this looks very similar to the Cuisenaire rods in the concrete, right? I love how these tape diagrams or bar models can be concretely shown with our Cuisenaire rods. Really powerful. As we move into the abstract representation, we want to connect these representations. I can record that 14 divided by the 2 was the same as 7. I also can be thinking, of course, that 2 times something would be 14. And so our students can be thinking about their times 2 facts, right? Which also are related to their doubles facts. So it all comes together as we're working together to create these understandings that connect the multiplication and the division. The research is very heavy about students thinking about multiplication with their division facts. Want to be sure to explore dividing by 2 in the other context in terms of taking, in this case, it's going to be 12 animals and splitting them in half. So we end up having 2 groups of equal size. It's not how many groups of 2 are there in 12, it's how many 2 groups there would be if there's equal amounts in both. So again, we're dividing by 2 and the Cuisenaire rods is our model. So if I want to enter this task concretely, I might begin with drawing out the flexible rod and then making it be the distance that I want it to be the 12. But I remember I also could drag out the rods that have the 10 and then the amount above the 10 and to be the teens. Now I'm going to choose to do this right now for this example here. At this point, we need to figure out what is half of 12. What can I have 2 of that would make the total of that 12? Now, if students don't know that 2 sixes is 12, what could be their thinking? How can we help them figure out what this is? Now, I'm always mindful of the later connection to larger numbers they'll be doing and how halving is such an important skill to be able to do within multiplication as we're working on strategies like double and halving, right? We have to be able to halve. And I like to encourage kids to maybe break it apart in ways that allow us to find halves of smaller chunks. Now we can set this foundation for this thinking here by showing this 10 and the 2 for the 12, because I can think about, well, what's half of 10? And a lot of our students know 5 and 5 is 10. So 2 5s make a 10 and 2 1s make the 2. So I can think about having the 10 and having the 2 and putting those 2 partials together. What if I rearrange these rods to show that it must mean that 2 6s would total the 12, right? But I got there by actually having the 10, having the 2, and putting those 2 together. So being able to come to that conclusion that indeed 2 6s, 6 times 2, makes that total of the 12. Now, pictorially, if they have some 10 frames, they could be drawing out 12 symbols. So again, if I just do 12 circles, but what if I draw the circles like this? So I don't fill it like a top fast 5 on the top row, but I be able to do this. So I can visually see, well, that total amount is 12. So what's half of that? Well, it's 2 6s are within that 12. So I can be visibly seeing the 2 groups, the 2 equal groups that make up a 12. As we have the tape diagram model of the structure of the situation, if I were to put a symbol in for the unknown, I would put 12 animals in all. And at the moment for the unknown, I might say, well, horses and cows is going to be half and half. But what I don't know is how many each would be horses and cows. Although I do know it's going to be the same, right? It's going to be 2 equal sized groups. So I can put a symbol in there temporarily, and of course variables as students are working in the upper elementary as well, to stand for what those values are going to be. So the question is, how many horses were there? Well, when I determine that the 2 6s makes 12, then it would end up being those 6 horses, right? And so abstractly, I can record it, and let's this time do the unknown. The I don't know is the same as 12 divided by 2. And I don't know what that is yet, but it's going to turn out to be, of course, 6 is the same as 12 divided by 2. I also can frame that multiplicatively. That mean that 2 times something, again, must be 12. And I've figured out that it's going to be 6. 2 groups of 6 make 12.